Hi everyone. So in this video we are going to see the non-linear application of OpAmp. Okay. So there are many non-linear application of OpAmp. So first application is exponential amplifier. So what do you need in this one? You need your output voltage to be proportional to the exponential of input. This is what you need. Your output voltage should be proportional to the exponential of input. This is what you need. That's it. So you made this configuration. So for a diode, if you know the characteristics of diode, this is your diode. Now for the diode, this is your forward potential Vd. Then what is your current Id? That is given by Is e to the power Vd upon eta Vt, right? Since there is negative feedback involved, there is a negative feedback, right? So this potential will be 0. This is 0, then this will also be 0. So this potential is 0. So tell me, what is your V0 voltage? V0 voltage is minus Id into R, because this same Id current is flowing here. This drop will be Id into R. So V0 will be minus Id into R. What is your Id? Id is this expression. Id is Is minus Is into Vd upon minus Is into e to the power Vd upon eta Vt into R. Right? Tell me, what is Vd? Vd is equals to V in only. Say yes or no. Across the diode, how much potential is there? Vd is equals to V in only, because this is 0 and this is V in. So Vd is equals to V in only. Very easy. So minus Is into V in by eta Vt R into R. Into R I can write here. So minus Is into R e to the power Vd upon eta Vt. That's it. This is your V0. This is your V0. This is your V0. So here, what do you see? Your V0 is proportional to e to the power Vd upon eta Vt. Right? So this is what we wanted and we achieved it. Not Vd. Sorry. Vd is equals to V in. So I need to write V in here. Sorry. I need to write V in here, because Vd is equals to V in only here. Here I am writing Vd is equals to V. That's it. So this is what we wanted and we achieved it. Right? So this was the application for exponential amplifier. Let's see logarithmic amplifier. This is your logarithmic amplifier. So what you want now? You want your output to be proportional to your logarithmic of input. You want your output to be proportional to the logarithmic of input. This is what you want. So what you will do? Let's check that out. So what is the current flowing here? V in by R. The same current is flowing through this diode as well. V in by R current is flowing. What is the Vd potential here? Tell me. What is the value of Vd potential? Since there is negative feedback, so this node will be also 0. Right? This node will also be 0. So what is your V0? V0 is equals to minus Vd. Say yes or no. This node is 0, this node is V0. So what is your Vd? Vd is minus V0. You can write Vd equals to minus V0 or V0 equals to minus Vd. Both are same thing only. So Vd is minus V0. Now what is the current flowing? What is the equation of diode current? That is Is into e to the power Vd upon eta Vt. This is the equation of diode current. Right? This is the equation of diode current. Now tell me, what is your Id? What is your Id? Id is V in by R. Say yes or no. Id is V in by R. Is into e to the power. What is Vd? Vd is minus V0. Eta Vt. Right? So what you can write? E to the power minus V0. This is not Vd, this is V0. This is V0. So I am writing it something like this: exponential minus V0 upon eta Vt is equals to V in by Is into R. So what do you get from here? Minus V0 by eta Vt is equals to ln V in by Is into R. So what do you get? V0 is equals to minus eta Vt ln Vi upon Is into R. That's it. This is your final output voltage. So what did you understand here? Your output voltage is proportional to the logarithmic of input. Say yes or no. Although there is some constant factor as well, there is constant factor of alpha as well, because here is into r you are also getting, but it is certainly proportional to the logarithmic of the input, right? This is what you needed and you achieved it. Simply by using the diode, we made logarithmic amplifier as well and exponential amplifier as well. Well and good, very easy application. You just need to write down the current equation. You just need to see how Vd can be replaced. Here Vd is equals to minus V naught. In the previous question, Vd was equals V naught was equals to minus I naught into R minus Id into R, and Id was proportional to the input only. So with respect to input, you could write Id equals to Is e to the power Vd upon eta Vt. Vd was equals to V only. So from here you could get this expression. Now you could get this expression. Well and good. So this was one of the easiest property. This was one of the easiest application. Now we will move to different applications. But let's just see, why do we need a OpAmp? Okay, why do we need an OpAmp to make a half wave rectifier? So what is the half wave rectifier that we have generally studied? This is a very simple half wave rectifier that we have already studied. So what it will do, if Vin is equals to positive, then it will pass, and if Vin is equals to negative, it will not pass. So for Vin equals to positive, we will get this and then 0, then again this, then again 0. This is a simple half wave rectifier circuit. But here the gamma value is 0.7 volt. The gamma value is 0.7 volt, and your input is very small. Input is a small signal, that is 20 millivolt to minus 20 millivolt and 20 millivolt minus 20 millivolt. So your input is basically 20 millivolt sine omega t, and V gamma is equals to 0.7. So tell me, will this diode turn on? Will this diode turn on? No, the diode will not even turn on. Diode will never turn on. So your output will always be 0. Your V naught will 0 volt. Your V naught will always be 0 volt. That's it. Your V naught will always be 0 volt. Look, you wanted to use the diode as a half wave rectifier, but your input was very small. But your diode was having a forward voltage, forward drop of 0.7 volt. Cut-in voltage was 0.7 volt. But even the peak value was not 0.7 volt. So the diode was not able to turn on. So now this is the issue, that you have a diode, but your diode is not able to turn on. So what you will do? You will use an OpAmp, and using that OpAmp you will make a half wave rectifier circuit. Using that OpAmp you make a half wave rectifier circuit. So now we are going to study half wave rectifier circuit using precision diode. So this particular circuitry is working as precision diode. How it is working as precision diode? Let's check that out. So the input is applied. What is the input? This is the same input. The same input is being applied. But here I will write down a point that here this circuit is not working as half wave rectifier because V in max is less than V gamma, right? But even if there is V gamma, still we want it to work as a half wave rectifier. So this circuitry we are going to use. So let's check out the analysis of this particular circuit. So how we will do the analysis when there is a diode connected in an OpAmp? You see an OpAmp and there is a diode connected. So what will be the analysis you will be doing? So let's check that out. We will see a lot of example in the next video. Only we are going to solve an assignment as well. So after that we will see a lot of example in that assignment. So it will be more clear to you. But let's understand one by one. So you will build a very good concept. So what we are going to do, we will first apply open circuit test, because our aim is to check the operating condition of this diode, whether this diode is on or off. So our aim is to check the operating condition. So what we will do, we will apply open circuit test. Apply open circuit test. So I am applying open circuit test. So what I will do is that I will copy the same circuit and I will open circuit this diode. So this diode is open circuited. This has a V gamma of 0.7. We are not going to forget it. This has a V gamma of 0.7. This diode is open circuited now. The same diode we are using. This is the same diode we are using, and our target is to amplify this signal. Our target is to amplify this particular signal. Okay, forget it. Yeah. So this open circuit test we are applying. Now tell me what is the current here? 0 ampere, right? There is 0 ampere current here. Now the same 0 ampere current will be flowing here as well. Same 0 ampere. So this 0 volt will be, since there is 0 ampere current, so there is 0 voltage drop. Across this RL there is 0 voltage drop. So this 0 will travel and it will reach here. So if you are applying open circuit test, this node is at 0 potential, this node is at V in, right? If your V in is less than 0, if your V in is less than 0, what will be this node? Let's just call this node as V node dash. Your V node dash will be, if V in is less than 0, positive potential is lesser than 0, so your V node dash will be minus V set. If it is minus V set, this node is minus V set. The P side is at negative potential. P side is at negative potential and N side is at 0. P side is at negative potential and N side is at 0. So the scene is, this is the diode, this is at negative potential and this is at 0. So what is happening? Your diode is off. Diode is off. So if diode is off, this is your final circuitry, no? You applied the open circuit test, you got to know that diode is off. So if diode is off, this is your final circuitry, right? This is your final circuitry. If this is the final circuitry, then what is your V0 value? It is equals to 0 only. Did you understand this? Your V0 is 0 only because this is your final circuitry. If this is the final circuitry, that means there is 0 current in the input of OpAmp, there is 0 current. The same current is flowing through RL. The same current is flowing through RL, so your V0 is 0. This is not where you are collecting the output. You are not collecting your final output across the output of the OpAmp. No. You are collecting your final output across RL. Across the output of OpAmp, I connected a diode, and to the N terminal of the diode, I am collecting my output. So this is my final output. So if diode is off, if diode is off, if diode is off, so what is my final circuitry if diode is off? This is only my final circuitry is. It is very important to understand this because it is very important with respect to your examination. And many guys don't understand this concept that much deeply. So here diode is off, so there is 0 ampere current flowing. So let's forget about this 0 volt. So if diode is off, there is no feedback. There is no feedback because diode is off. There is no feedback. So there is no feedback, and there is no feedback. There is 0 ampere current here. This is also 0 ampere current. So in RL there is 0 ampere current. So what is the voltage drop here? That is 0 volt only. So what is the V0 voltage? V0 voltage is 0 volt. V0 voltage is 0 volt for which case? For V in less than 0. This is the case for V in less than 0. You applied open circuit test for V in less than 0. Now again I am going to apply the open circuit test but for V in greater than 0. Now I will check for V in greater than 0. This is how we check in half wave rectifier as well. We apply the open circuit test, right? We open circuit this diode. Then we check if V in is greater than 0 then diode is off. If V in is less than 0 then diode is, if V in is greater than 0 then diode is on, and if V in is less than 0 then diode is off. The same thing we are doing here. So the same circuitry I need to copy. Now I am going to apply open circuit. Again I am applying open circuit test for V in greater than 0. So here only I can write for V in greater than 0. This is our circuitry. Okay, this was the case for V in less than 0. For V in less than 0, it was minus V set. Yeah, okay. Now for V in greater than 0. For V in greater than 0. For V in greater than 0, this was your V naught dash, right? So what is your V naught dash for V in greater than 0? For V in greater than 0, your V naught dash will be plus V set. Say yes or no. This node will be plus V set. So what is the scene now? The diode was connected something like this. You are applying open circuit test. This node is at plus V set. This particular node is at plus V set, and this node is at 0. And this node is at 0. That means diode is on. Diode is on. And if diode is on, what will happen? It will be replaced with the battery of 0.7, but in the opposite direction, like this. It will be replaced with the battery of 0.7, right? So diode is on now. So how will the circuit look like? Now the diode has become on. For V in greater than 0, you applied the open circuit test and you got to know that your diode is becoming on now. So if diode is becoming on, then it is replaced with the simple battery, which is this. This battery is 0.7 volt. This battery is 0.7 volt. Now what is happening is that there is a feedback circuit present. What is present? There is a feedback circuit present. Although the current here is 0 ampere, the current still here is 0 ampere. The current still here is 0 ampere. But now you cannot say that current here also will be 0 ampere. No, no, no. Why? Because this is the output path. This can drive some current. This can drive some current. This can also drive some current. So now the current is not 0. Are you getting this point? What did I do? I applied the open circuit test. I got to know that this potential is plus V set. If this potential is plus V set, my diode is on. If my diode is on, I can replace it with the simple battery. That's it. Then I got to know that there is a negative feedback present. So what I can say is that there is negative feedback present. So if there is negative feedback present, then this V in will be simply copied here. If there is negative feedback, that means virtual short is valid. Virtual short is valid. Virtual short is valid only when there is a negative feedback. So this V in is present and this V out is equals to V in. So your V out is equals to V in. That's it. So what did you get to know? What is the conclusion? For V in greater than 0, your V out is equals to V in. And for V in less than 0, your V out is equals to 0 only. And here there is no use of this battery, right? Even when your diode was having some forward voltage drop, even when your diode was having forward voltage drop of 0.7, but since you use this OpAmp circuitry, then this particular voltage was having no effect, because your V set will be certainly greater than 0.7. You can put your V set to be plus 5. So if your V set is plus 5, certainly it will be on. Your V set will be plus 5. Now what will be this V naught dash value? Can you tell me? What will be the value of V naught dash? V naught dash value will be plus V set or something else. V naught dash will not be plus V set now. V naught dash was plus V set when we were applying the open circuit test. When we were applying the open circuit test, at that time V naught dash was plus V set. But now, after applying the open circuit test, we got to know that our diode is on. If our diode is on, this node is V in. This node is V in. So what is your V naught dash? Your V naught dash is V in plus 0.7. Your V naught dash is V in plus 0.7, but that is of no use. That is of no use. My target was to find this V naught. So my this V naught is equals to V in. Did you get this point? First, I got V naught dash equals to plus V set only when I was trying to check the operating condition of diode. I checked the operating condition of diode and I found it that it is on only. If diode is on, I replaced it with the battery of 0.7. Now there is a negative feedback involved, so this V in will be simply copied here because the concept of virtual short is valid. So my V naught is simply equals to V in. That's it. So even for a small signal, your output is amplified. Say yes or no. Even for a small signal, your output is amplified now. In the previous case, in this case, 20 millivolt was the input signal, but your output was not able to amplify. Sorry, not amplify, I should not say, rectify. So even for a small signal, you are not getting any output. You are using it as a half wave rectifier, but since the signal was small, so you are not getting any output. But now the signal is small, still you are getting some output. Why is it so? Because you are using the diode, you are using the OpAmp now. In OpAmp, there is no use of this 0.7. Just if Vin was just greater than 0, it can be 0.0001, it can be 10 nanovolt as well, it can be 10 femtovolt as well. So even if this much of low voltage is there, still output will be plus Vset. If output is plus Vset, that means the diode is certainly turning on. If diode is turning on, Vin will be simply copied here, or your Vout will be equals to V. Say yes or no. Right? So even the small signal is being amplified here. So what was your input voltage? This was your input voltage. Now it is being half wave rectified. What will be your V naught? For V in greater than 0, it was giving you the same, and then 0. Then again the same as input, then again 0. Then again same as input, and so on. Right? This was peak 20 millivolt. This is the output you are getting. So you used a too much of you. Okay. So you used a precision diode. Why this particular circuitry is known as precision diode. This much of circuitry is known as precision diode. So this is a precision diode only. Why is it precision diode? What do you mean by precision diode? Because at the final output, if Vin is just greater than 0, even if the particular diode you are using that has a cut-in voltage, but still if your Vin is just greater than 0, just minute greater than 0, still it is giving you the same as input, and if it is less than 0, it is giving you 0 voltage. That's it. So that's why it is known as precision diode. Are you getting this point? What I mean to say is that if you are using this diode, then to turn on this diode you need Vin should be greater than 0.7 volt. But now to turn on this diode only, using this particular circuitry, using this much of circuitry, using this particular circuitry, if your Vin is just greater than 0, if your Vin is just greater than 0, then this circuitry would act as a short circuit only. This circuitry is acting as a short circuit only, because if Vin is greater than 0, your output is becoming equals to Vin only. Let's just say this is your output. Let's just say this is your output. So your output is becoming equals to Vin only, and for Vin less than 0, this diode is becoming off, and your output is equals to 0 volt. Well and good. So this was the half wave rectifier using precision diode. Let's check out other applications as well. So using precision diode, I am writing using precision diode. Also, even for larger signal, there is also one advantage. What do you think? What is the advantage? Let's just say, what I mean to say is that let's just say this input voltage was 10 volt, right? This input voltage was 10 volt, and you are using this particular circuitry for half wave rectification. Then what you would have got in the output? You would have got in the output something like this, right? And this peak value would have been 9.3 volt. Say yes or no? If you are applying 10 volt here, this peak value would have been 9.3 volt only, because this would eat up 0.7. 10 minus 9.3, 10 minus 0.3 is equals to 9.3. But this case will not happen if you are using this particular circuitry, because for Vin greater than 0 only, this diode will be turning on, and V naught will be simply equals to Vin. So this thing will not be happening in this particular circuitry, but in this particular circuitry your peak value was less. Your peak value was 9.3 only, and you needed to apply Vin greater than 0.7, then only diode was turning on. But here the diode is turning on for just greater than 0. Let's move to our next configuration. Now, before moving to our next configuration, there is one simple question that OpAmp is an active device, active element or passive element. So what do you think? It is active element or passive element? So when I was teaching you active element, when I was teaching you the definition of active element in the first lecture of network theory, I taught you the definition of active element. So what is the quality of active element? They need an external energy source to operate. They need an external supply like transistor. They need an external supply. They have the ability of internal amplification. They can amplify. That you are applying Vin voltage, you can get 2 Vin. Using the resistor, you can never get 2 Vin. You can get Vin by 2. Using the resistor, if you are applying Vin, you can get Vin by 2. But using the transistor, if you are applying small signal Vin, you can get 10 Vin, 20 Vin, 30 Vin. Same with OpAmp. We have seen inverting amplifier, we have seen non-inverting amplifier. If I apply Vin, I can get 1 plus RF by R into Vin. If I apply Vin input, I can get 1 plus RF by R into Vin. And we studied the internal structure of OpAmp. What was the internal structure of OpAmp? In the last lecture of, in the last only, we studied the internal structure of OpAmp. We made an OpAmp using the transistor only. So this was the internal structure. And then there was further stage as well. Common source stage was there, then common drain stage was there. So this was the internal structure. So all these transistors need VDD bias, right? They need this VDD bias to operate. So they need an external supply, right? They need an external supply. There is a property of internal amplification, and it can deliver the energy as well, because we saw some questions on OpAmp. Then I told you, I asked you to find this I naught value. So from OpAmp there is some current coming out, so it can deliver the energy. Are you getting this point? Resistor can take the current. It's not that resistor can deliver some current. If resistor is delivering some current, that means it is a negative resistance. But OpAmp can deliver the current. The input resistance of OpAmp can be negative as well. From some node, the resistance can be negative as well, right? So it can deliver the energy as well. Also, it runs on the supply. Also, it has the ability of internal amplification. So what kind of device is that? Active device is it? So OpAmp is an active device. Active element or active element I am going to write. OpAmp, MOSFETs, BJTs, all are active element because they need external supply. Also, they have the ability of internal amplification. Also, they can deliver the energy. So when you study different application of OpAmp, no, so there will be again and again written active half wave rectifier, active filters. So active will be written there. So what do you mean by active? Active means you are using OpAmp there. That's why. So here active half wave rectifier. What do I mean by active half wave rectifier? I am using the OpAmp. I am using an active element. That is OpAmp. You are certainly using passive element there. This RF is passive element. This is also passive element. But you are also using one of the active element as well. You are using OpAmp. So that is an active element, right? So you are using an active element. That's why it is called active half wave rectifier. So again, you can do the analysis of this one. Try doing the analysis on your own. Apply the open circuit test. Get to know this potential. Let's just call this potential as V0 dash. So comment on V0 dash, then think which diode will be turning on, which diode will be turning off. So let's start one by one. We will apply the open circuit test. So applying open circuit test. So I will open circuit these diodes. These diodes will be open circuited. I also should write down the polarity P N. This was also N P, right? Now tell me one thing. Okay, there is 0 ampere current, but forget about it. Currently there is no feedback involved, no? There is no feedback. No portion of OpAmp output, no portion of OpAmp output is coming towards the input. There is no feedback involved, right? So there will be zero current in this RF. Say yes or no. There will be zero current in this RF, right? There will be 0 ampere current here as well, right? Now you can directly say if your Vin is greater than 0, then it will affect your negative node only. Say yes or no. Look, what I mean to say is that there is 0 ampere current here. This is an open end. This is an open end, right? So there is 0 ampere current here as well. If there are 0 ampere current, that means there is 0 ampere current here as well. If this is also an open end, this is also this resistor is also open ended. So there is 0 ampere current here as well. That means there is also 0 ampere current. So this Vin is directly coming here because there is 0 voltage drop across this resistance. So this Vin will travel here only. Say yes or no. I applied the open circuit test. I applied this open circuit test. This was open ended. This was open ended. Everything was open ended. This Vn was directly coming here. This node is Vn. So if I say, what do I say? If Vn is greater than 0, what will be my V node dash? This is Vin, this is 0. This is 0. V negative node is 0. Vin is greater than 0. V negative node is greater. If V negative node is greater, that means my output will be minus V set. So this is my output, which is minus V set. If it is minus V set, then which diode will turn on? This one. This diode will turn on. So let's just call this as D2, this as D1. So if V node dash is minus V set, then which one will turn on? D2 will turn on. D2 turns on. If D2 turns on, then what happens? Let's check that out. So if D2 turns on, I have to add a lot of pages because there will be circuitry again and again, again and again. If D2 turns on, it will be replaced with the battery of 0.7. Right? And this will be off only. D1, because V node dash is minus V set. P terminal is connected to minus V set. And D1 is off. So this node is becoming off. Forget about this node. This node is becoming off. And forget about this V node dash as well. Right? Now there is a negative feedback involved. Say yes or no. From output, some portion is coming towards the input. That too towards the negative terminal. So there is a negative feedback involved. Say yes or no. From output, some portion is coming towards the input. So there is a negative feedback involved. If there is a negative feedback, then this node will be 0. Say yes or no. Because there is virtual short valid. Negative feedback is present. Negative feedback is present. If negative feedback is present, that means this node will be 0. Say yes or no. No doubt about it. Okay. This is an open end. This resistor is open ended. So certainly there is 0 ampere current. There is 0 ampere current here. You cannot say here there will be 0 ampere current. Why so? Because now this is connected to the output of the OpAmp. Output of the OpAmp can drive some current. So there is some current that can flow like this. And the current has other path as well. It can flow from here as well. But it cannot go into this. So what do I mean by that? Whatever the current is coming here, that can flow like this. Say yes or no. From output of OpAmp, some current come. It is coming. It cannot go here. So it can go towards the input side like this. So you cannot say that in this branch there is 0 ampere current. You cannot say that. You cannot say in this branch there is 0 ampere current. But one thing I can say that this is open ended. So in RF there is 0 ampere current. That's for sure. There is guarantee about it. Say yes or no. And there is also guarantee that there is a negative feedback present. So certainly virtual short is valid. So if this node is 0, this node will also be 0. Now there is 0 ampere current. This node is 0. This node is 0. So this 0 volt will be traveling downwards. 0 only because if there is 0 ampere current, that means there is 0 voltage drop. So this 0 volt will be traveling down to 0 volt. Say yes or no. Many guys know this particular circuitry would work as half-wave rectifier, but they don't know the region. this is the particular region, this is the exact region that you applied the open circuit test, you got to know that this diode is turning on, the other diode is turning off. If this diode is turning on, other diode is turning off, there is negative feedback present. So this V0 is traveled here, this 0 can travel here as well. But since this is open end, this RF is driving 0 ampere current. If RF is driving 0 ampere current, that means there is 0 voltage drop across it. So this V0 will travel down to, this 0 volt will travel down to V0. That's it. That's why your V0 is equals to 0 volt. For V in greater than 0, your V0 is equals to 0 volt. And if someone had asked you, what is the value of I0? If my question was, what is the value of I0? So this complete I0 is flowing like this. This complete I0 is flowing like this. Say yes or no. I0 is flowing like this. What is the current coming here? If this node is 0, this node is 0. So what is the current coming here? This is V in by R. So I0 is basically minus V in by R. Do you agree to my point? That is of no use, but in the question sometimes they can ask you, if V in is greater than 0, what is the value of I0? I0 is minus V in by R. This I0 is traveling like this. So that is minus V in by R. I0 is equals to minus V in by R. Right? This current is I0 only. So, but these questions are rarely asked, but they can ask if they are trying to frame a good question. These kind of things they are going to ask, the value of current, because people don't know this. They just know that this is working as a half wave rectifier. But what is actually happening in the circuit? How much current is going? How much current is there? How output voltage is 0? That is important to know. So this we checked for V in greater than 0. Now we are going to check for V in less than 0. So we are applying open circuit test only. Now we are going to check for V in less than 0. Applying open circuit test. The same test we are applying. Let's just remove all those. Okay, all those things can be there as well. There is no issue. For V in less than 0, what will be my output? V negative node is lesser, so my output V node dash that I am calling will be plus V set. So this my output will be plus V set. Now this was my D1, this was my D2. So my D1 turns on. D1 turns on and D2 is off. So if D1 turns on, then this will be replaced with the simple battery of 0.7, right? So I guess I can copy this circuit only. No, I will copy this simple circuit only. So D1 turns on and D2 is off. This will be replaced with the battery of 0.7. And this will be open circuited. D2 will be open circuited. So this feedback is not present. This feedback is not present, but this feedback is present this time. Say yes or no. There is certainly a feedback present. Some portion of output is coming towards the input. So there is certainly a feedback present. That means this node will certainly be 0. Say yes or no. Now can you say that through RF there is 0 ampere current this time? No. Because RF is coming into this loop. RF is coming into this loop. The output of OpAmp can drive some current. I0 current. This current can flow from here. This current can flow from RF. So output of OpAmp can drive some current. So certainly this RF is not driving 0 ampere current this time. Now this node is 0. Right? What is the current going here? This is an open end. This is an open end. So what is the current going here? 0 ampere. What is the current going into the OpAmp? That is certainly 0 ampere. 0 ampere. So what is the current coming from here? 0 ampere only, because here there is 0 ampere current in this loop. Here there is 0 ampere current. So how much current is coming here? 0 ampere only. Say yes or no. This current is also 0 ampere. So at this 0 voltage node, I am applying nodal. So what will be my nodal? 0 minus V in by R plus 0 minus V node by RF. 0 minus V naught by Rf is equals to 0. Is equals to 0 only, because this is 0 ampere current. So 0 minus V in by R, 0 minus V naught by Rf. That's it. 0 minus V naught by Rf. That's it. I need the V naught voltage, nothing else. This 0.7 is of no use now, right? Because my V naught is not depending on this 0.7. I am not talking about this V naught dash. Is this V naught dash plus V set now? Is this V naught dash plus V set now? No. This V naught dash is V naught plus 0.7. It is not plus V set. Why it is not plus V set? Because in the previous case we were just checking. When we got to know that it is plus, it can be plus V set, then diode will turn on. If diode is turning on, there is a negative feedback present, so it will completely change the circuit. So your V naught dash is V naught plus 0.7. And what is your V naught? Your V naught is minus Rf by R into V in. This is your V naught. For which case? For V in less than 0. For V in less than 0. So what is the final conclusion? For V in greater than 0, your output was 0 volt, right? Here we got to know, for V in greater than 0, your output was 0 volt. Your output was 0 volt. And for V in less than 0, your output was minus Rf by R into V in. So if I draw this waveform, if I take this waveform, forget about this precision diode, forget about this amplitude as well. It can be anything, it can be any amplitude. Let's just write it as A and minus A. A can be 1 nanovolt as well. It can be 1 nanovolt as well. It can be 1 microvolt as well. It can be 1 millivolt as well. Even minute to minute. It can be anything. So how will the output waveform look like? How will the output waveform look like? So for 0 to t by 2, if Vin is greater than 0, for 0 to t by 2, it will be 0 only. For t by 2 to t, it will be negative of Vin, minus Rf by R, factor of minus Rf by R, negative of Vin. So negative of Vin. So what will be this amplitude? This amplitude was minus A into minus Rf by R. So this amplitude would become A into Rf by R. Say yes or no. So this amplitude would become A into Rf by R. So this amplitude will be A into Rf by R. And again for the next cycle, this will be 0 only. Then for the next cycle, it will again be A into Rf by R, and it will go on like that, right? Say yes or no. No issue about it. So this is how your output waveform looks like. So this was a half-wave rectifier, but we rectified the negative part this time. Well and good. Okay, so these kind of questions can come in the examination. They can give you a particular circuitry and then they can ask you this waveform. They can ask you the transfer characteristics as well. Transfer characteristics. Transfer characteristics. What do you mean by transfer characteristics? We have seen it a lot of time. CHARA. Still I don't remember the spelling. What do you mean by transfer characteristics? Look, during the class I don't make much of jokes, right? देखो अब ज़्यादा जोक्स कई लोगों को ऐसा लगता है कि मजाक करना चाहिए क्लास के दौरान, बट मेरा मानना ये है, what I feel is that if you are studying, you should study with full concentration. If you have enough concentration, you will never get bored in the class. And the kind of concept we are teaching, the kind of depth we are going, so if you are fully concentrated, you are never going to feel bored. So that's why I don't make much of jokes in the class, but once I come live on YouTube sometimes, then you can join me. There I make jokes because that is for time pass and for your queries only. But here I don't prefer making some jokes and all those things, because I kind of feel that people will be learning here rather than focusing on entertainment. I have seen a lot of teachers doing entertainment needlessly in the class. So yeah, forget it. So we are drawing V naught versus V in. V naught versus V in. So for V in greater than 0, your V naught was 0 only. For V in greater than 0, your V naught was 0 only. So I can make it But for V in less than 0, there was a negative slope, minus RF by R. The slope was negative. This is a positive slope. Do you remember? This is a positive slope. And this is a negative slope. But you need to draw it for V in less than 0 only. So since this is a negative slope, so this is how you will make. So here your V naught is minus RF by R into V in. That's it. Well and good. Okay. Let's move to our next circuitry. Before moving towards the next circuitry, let's solve a particular problem. Now you don't know what kind of rectifier it is that. Is it a rectifier or not? What is this circuitry? You don't know. You just need to analyze it. And V gamma should be given in the question only. V gamma is there. Or V gamma we should not take. Or we should take. Will there be any effect on V gamma? Let's check that out. I don't think there will be any effect. Since they are connected in feedback only, I don't think there will be any effect towards the output. Okay, so let's take V gamma. In the examination, V gamma can be 0 as well, but let's just take V gamma is equals to 0.7. Okay. Now, what I am going to do this? What I am going to do with this? If you remember the previous lectures, I told you I am going to apply superposition theorem whenever I see these kind of circuits. Can I replace this circuit something like this? This node can be simply coming here like this. That's it. And these are source gate only. So I am going to replace this as a single voltage source and a single resistance. So simply this is what I am having. For the ease of calculation, I am going to do this. This is R, this is R, this is V, this is 2 volt. And then there is this further circuit connected. There is this circuit. I can write this is a circuit. What I am going to do this with this? I am going to apply superposition theorem. So how I can replace it? What will be the potential of this node? I am finding VTH. For finding VTH, VTH is a open circuit voltage. So there will be 0 current from here. So what will be the potential of this node? V in into R plus 2 into R divided by 2R. V in into R plus 2 into R divided by R plus R, that is 2R only. Right? So it would be V in plus 2 by 2. So this node will be V in plus 2 by 2 and I am finding RTH. So this will be shorted, this will also be shorted. So R parallel with R will be R by 2. So how I can replace it? I have solved the same question, so you should not be confused. So how I can replace it? This R parallel R will be replaced by R by 2 and this node will be V in plus 2 by 2 and this will be the circuit. Right? So this much of configuration I can replace V in plus 2 by 2. For the ease of calculation, without even doing that, you can also do the calculation, but I prefer doing it. Whenever I see any circuit, I try to apply as much superposition theorem as I can so that I can reduce the circuit. So it is my habit. You can also do it. If you don't like doing it, you can certainly solve it without this without this conversion as well. So yeah, let's copy this circuit now and let's analyze it. So the same way we are going to analyze. Whenever I see any diode, there is the same way. What is that way? That open circuit the diode, apply the open circuit test, apply other tests. Open circuit test, then you see if your diode is on or off. I have replaced the circuit by resistance R by 2 and this potential is V in plus 2 by 2, right? V in plus 2 by 2. Okay. I am applying open circuit test now. This diode will be open circuited. Now tell me one thing, in the examination, if you again and again apply this open circuit, then you have to draw the models and all those things. In the examination, what you will do? There is simple formula. There is simple thing. If this potential is coming towards the negative terminal. If this potential is greater than 0, if V in by 2, V in plus 2 by 2 is greater than 0, then what will be this node? This node will be V node dash node will be minus V set. Say yes or no. V node dash node will be minus V set, then this diode will turn on. And if it is minus V set, then this diode will be turning off. So you can here to the diagram only I am showing the polarity P and P. If your V naught dash is minus V set, then this diode is turning on. Let's just call this diode as D2 and this diode as D1. So D2 turns on. Actually, in the examination, you don't need to think about current and all those things. No need to think about current and all those things. Here you also need to see the current actually. But in the examination, don't see the current. Okay, what is the current if this node is directly coming here or not? Because there can be doubt, no, that sir, this is it. Are you sure that this node is directly coming here? Because there is R by 2 connected as well. What will happen to this R by 2? There will be zero current through this R by 2. Why so? Here there is 0 ampere current, right? This node is open-ended. V node is open-ended. So certainly there is 0 ampere current through this as well. There cannot be any current here. So this is also 0 ampere current. So here also there is 0 ampere current. If in these two nodes there is 0 ampere current, so certainly through this R by 2 is also 0 ampere current. That's why this V in plus 2 by 2 is directly coming here. But in the examination, you are not going to think that much. Okay? If you want to think, you can think. If I had been a student, I would have thought. Because what if IIT's professor framed a very good question where you need to check the currents? But till now, 100% of the questions have been asked where you don't need to check. You just need to think, okay, this V in potential is connected to this one, right? And when we simplified it, this V in by 2 is connected to this node. So that means if V in by 2 plus 2 is greater than 0, then my output will be minus V set. And if it is minus V set, then this diode will turn on. That's it. This is what you need to think, and this diode will be turning on. This is the only thing you need to think. That's it. Nothing else. Okay. So this diode is turning on. If this diode is turning on, D2 turns on and D1 is off. D1 is off. Then how will your circuit look like? Okay. So this I have already placed with single resistor and a single voltage source. This is your R by 2 and this is V in plus 2 by 2. Now this diode is off. So there is no feedback here because that diode is off. The diode was off, so there is no feedback, there is no meaning of making this one. And now this will be replaced with the battery of 0.7. Okay, this node is 0. Simply you can write V naught by V in. V naught by V in plus 2 by 2. If your V in plus 2 by 2 is greater than 0, that means if your V in is greater than minus 2. So all this is happening when V in is greater than minus 2. If V in is greater than minus 2, then your D1 is on. So you are saying that for V in greater than minus 2 volt, this is the circuit. For V in greater than minus 2 volt, this is the circuit. So this node is V naught, this node is also V naught. At this 0 node, you can apply nodal. So what will be the nodal? I am directly writing the output. What will be the output? Output will be minus RF by R into V in plus 2 by 2. That's it. This will be your output. Minus RF by R, not R, R by 2. Minus 2 RF by R, V in plus 2 by 2. Or you can write minus RF by R into V in plus 2. This will be the output for V in greater than minus 2. If this potential was greater than 0, then your diode D2 was turning on and D1 was turning off. So this would have become the circuit. Now there is a negative feedback present. Since there is a negative feedback present, so there is concept of virtual short is valid. So this 0 will be carried here. Now you can apply nodal as well, or you can directly see it is a simple inverting amplifier. This 0.7 volt is there, but that is of no use. Why is it of no use? Because this is V naught, this is your V in by 2. So 0 minus this potential divided by R by 2, 0 minus V naught divided by RF is equals to 0. So V naught will be becoming RF by this resistance R by 2 into V in plus 2 by 2. So 2 and 2 will be cancelled, minus RF by R, V in by 2. This is your output for V in greater than minus 2. Now we will check for V in less than minus 2. पेज ना खत्म हो जाए भाई. What I'm going to check, I'm going to do the same thing. Look, here I'm explaining you, that's why it is taking much time, but in the examination it will not take you much of time. Why so? Because you will be directly writing the expression once you have the enough practice. If this is less than 0, then what will happen? This V naught dash would be plus V set. If that is plus V set, then this diode will turn on, D1 turns on, and D2 is off. This diode is turning on and D2 is off. This diode is off. So what will be your equivalent circuit? Let's copy the main circuit only. Not the main circuit, because in the main circuit I will have to make R by 2 again and again. So I'm going to copy this circuit. Okay, this node is V naught. Okay, forget about this. So this is turning on now, right? And this diode is off. This diode is off. Now again there is a negative feedback present. Again there is a negative feedback present. This is a battery of 0.7 volt, but still from output of op-amp some part is coming towards the input. So there is a negative feedback present. If there is a negative feedback present, that means this 0 will be copied here. Say yes or no. If there is negative feedback, this 0 will be copied here. Now this RF is open-ended. Say yes or no. RF is open-ended, right? There is no path for the current to flow. There is no path. V node is not a node. V node is not a battery. It is simply a node. So it cannot drive any current. So this RF is again open-ended. 0 ampere current will be flowing here. 0 ampere. So through RF there is 0 ampere current. If there is 0 ampere current, then this 0 will be simply copied directly here. This 0 will travel here. Then there is no voltage drop across RF. So this is 0 volt. This is also 0 volt. So V naught is equals to 0 volt. Say yes or no. What did you understand? For V in greater than minus 2, here, sorry, V in less than minus 2. This is the condition for V in less than minus 2. This you made for V in less than minus 2. For V in less than minus 2. For V in greater than minus 2, your V naught was, what was your V naught? Your V naught was minus RF by R, minus RF by R, V in plus 2. And for V in less than minus 2, your V naught was 0 volt. That's it. Now you can draw the transfer characteristics. What is your breakaway point? This is your V naught. This is your V in. So where the things are changing? At minus 2. So for V in less than minus 2, output is 0. Output is 0. For V in less than minus 2, output is 0. For V in greater than minus 2, your output is having negative slope. Your output is having negative slope. Minus RF by R, that is a negative slope. This is the positive slope and this is the negative slope. So this will be the negative slope, right? So this is how it will go. The slope is minus RF by R. Slope is minus RF by R. And at V in equals to 0, what will be the output? This output will be minus RF by R into 2, but that is not an important point. So this is how the transfer characteristic is looking like. Okay. In the examination, you are not going to draw the circuits again and again. What you are going to do? First, you will reduce our circuit to something like this. Then you will get to know that if V in by 2 plus 2 is greater than 0, if this node is greater than 0, then what will happen? This output will be minus V set. Then this diode will be turning on. If this diode is turning on, that means this feedback will be present. If this feedback is present, then simply what will be your output? If this diode is turning on and this feedback is present, then what will be your output? This V naught will be coming here. You can apply simple node analysis. 0 minus V in by R, 0 minus 2 by R, 0 minus V naught by RF. You will get to know that your V naught is this minus RF by R, V in plus 2. You will simply write that expression. Then you will see if V in is less than 0, not V in, whatever the input voltage is V in plus 2 by 2. If that is less than 0, then what will happen? Your output will be plus Vset. If output is plus Vset, that means this diode is turning on. Then this diode is off. If this diode is turning on, that means there is a negative feedback potential, so this node will be 0. If this node is 0 and this diode is off, so this RF is becoming open-ended. So it is driving 0 ampere current. So this 0 will be traveled to the output. That's it. So for V in less than -2, your output is 0. For V in greater than -2, negative slope is there. Is there any issue? So very quickly you will be able to answer in the examination if your concepts are clear. These kind of questions are like, if you practice enough, these kind of questions are to be solved in just max to max 1 minute. In 1 minute only you will be able to solve these kind of questions if you have enough practice. Otherwise you will not be able to solve. Even like 95% of the aspirant will not even solve this particular problem, but that is very easy, right? And here they should have shown the threshold, saturation voltage. I forgot to show the saturation voltage, but this you can consider. Saturation voltage will be plus Vset and minus Vset, right? So this was the question. Now we will see this particular circuitry. I am not telling you if it is full wave rectifier or half wave rectifier, although the name is written full wave rectifier. But if this particular circuitry was there in front of you, and if I had asked you to analyze what is your output voltage, then can you do it on your own? Shall I keep it to you? Try doing it on your own, then watch the solution. So there are basically three kind of stages: one stage, second stage, and then the third stage. What is this stage? Can you name this stage? Differential amplifier, right? If I call this node is V01 and this node is V02, so what will be my output? Tell me. You should be able to remember this formula. This ratio by this ratio. First thing is you need to check the ratio from here to here, from here to here. Is the ratio same? R1 by RF, R1 by RF should be equals to R2 by R3, R2 by R3. Is that same? Yeah, it is same. 100 by 100 is 1, 100 by 100 is 1. So the ratio is same, right? So what will be your V0? RF by R, 100 kilo by 100 kilo into positive potential V02 minus V01. V02 potential minus V01 potential. Basically your V0 is V02 minus V01. Your V0 is V02 minus V01. So what I am going to do is that I am going to find the transfer characteristics of V0 and transfer characteristics of V01, and then I will subtract them. That's it, right? Okay, so let's find the transfer characteristics of V01. So I will pick this circuit. Now I am not going to explain from the right scratch. I am going to explain very quickly. I am going to explain very quickly, because from the right scratch, by drawing the circuits again and again, I have explained you a lot of time. So this is your Vin. Now I will tell you how you are going to solve in the examination, and this was your V01. Am I right? Okay. If Vin is greater than 0, if Vin is greater than 0, what will happen? This node is greater than 0, output will be minus Vset. Let's just call this as D2, this as T1. Output will be, this node is V0 dash. V0 dash will be minus Vset. If minus Vset, then what will happen? D2 on and D1 off. This is on. If this is on, there is a negative feedback potential, so certainly this will be 0. If this is on, this node is V01. There is certainly some current here because the feedback is there. Now there is no use of this. There is no use of this diode because this is open circuited. So there is no feedback here. So you don't need to think about it. So what will be your V01? Your V01 would be minus RF by R, minus 5 kilo by 5 kilo, minus 5 kilo ohm divided by 5 kilo ohm into Vin. So if Vin is greater than 0, your V01 is equals to minus Vin, right? And here the second condition we can check. If Vin is less than 0, if Vin is less than 0, then what will happen? If Vin is less than 0, your output V0 dash will be plus Vset. If it is plus Vset, then this diode D1 will turn on. D1 is on. D1 is on and it is plus Vset, then D2 is off. D2 is off. D1 is on and D2 is off. Then there is this, certainly this feedback is present. If this feedback is present, virtual short is valid. If virtual short is valid, this 0 will be carried here. This 0 is carried here. Now this node is open-ended. This node is open-ended, so it is driving 0 ampere current. And if it is driving 0 ampere current, then simply V01 will be equals to 0 volt only, because this 0 will be traveling here. Well and good. So V01 will be equals to 0 volt. So if Vin is less than 0, then your V01 is equals to 0 volt. So you can draw the transfer characteristics of V01. So for greater, there is a negative slope. So this is the positive slope, this is a negative slope. So you need to make a negative slope. And for V in less than 0, V01 is 0. This is your V01 versus V in. Right? Let's check out the other one. There are two configuration. This is the other configuration. The same input is applied. The input is equals to V in only. You understand that, right? This V in is coming here. The same V in is coming here, right? So I will copy the next circuit. This is your V02. So if V in is greater than 0, let's call this as D2, this as D1. So if V in is greater than 0, then your V0, let's just call this as V0 dash. So your V0 dash would be what? V in is greater than 0, your V0 dash would be minus Vset. If it is greater than 0, it would be minus Vset. Then which one will turn on? D1 turns on. D1 turns on and D2 is off. If D2 is off and D1 turns on, then certainly there is a negative feedback. If there is a negative feedback, then this 0 will be copied here. If this 0 is copied here, but D2 is off. If D2 is off, that means there is 0 ampere current here. D2 is off, that means there is 0 ampere current because it is becoming open-ended. So this V01 will be directly traveling, this 0 volt will be directly traveling to V02. Are you getting this point? Diode D1 is on, D2 is off. If D2 is off, there is no path for the current to flow. So this is driving 0 ampere current. And since there is negative feedback, so this 0 will be copied here and this 0 will be traveling towards the output. So V02 will be 0 volt only. So for V in greater than 0, your V02 is 0 volt. And for V in less than 0, your V0 dash would be plus Vset, right? For V in less than 0, your V0 dash would be plus Vset. Then what does that mean? That your D2 turns on. D2 turns on and D1 is off. D2 turns on and D1 is off. Then this is gone. There is no use of that. But this feedback is present now. This feedback is present. If this feedback is present, then simply this D2 will be replaced with the battery and this node V02 will be there. This current will not be 0 this time because there is a feedback present. This feedback is present. Output of the OpAmp can drive some current, right? There is some feedback present. If there is some feedback present, what does that mean? What will be your output? So your output will simply be, it is becoming as a inverting amplifier only. So what will be your output? Your output will be minus RF by R, that will be minus 5 kilo divided by 5 kilo only into V in. That's it. So for V in less than 0, your V0 is equals to minus V, right? V02. So what will be the transfer characteristics? This is your V02, this is your V in. So for greater, if V in is greater than 0, it is 0 only. And for V in less than 0, V0 is equals to minus V in. This is positive slope and this is negative slope. This is positive, but you need to make negative slope. This will be the negative slope. This is your V02. What was your final output? Your final output was V02 minus V01. So let's copy this. You need to draw the transfer characteristics only. Let's add one more page. Too much of pages we are adding. So here we are copying the final circuitry. What was your output? V02 minus V01. This was your V02. Let's copy all the diagram. Copy and paste. What about V01? This was your V01. This was your V01. Now you need to do V01 minus V02 minus V01, because you need to draw V0 versus V in. This is your target. You need to draw V0 versus V in. And what is V0? V0 is V02 minus V01 versus V in. So V02 minus V01. So V02 will come as it is. V02 is coming as it is. V02 is coming as it is. And then this is your V02. And what is your V01? V01 is becoming negative. So you have to make negative of that, like this. But these zeros I will not make. Why so? Because 0 plus some value, it will be 0 only. 0 plus some value, 0 only. 0 plus some value will be 0 only. So these zeros you can remove. So did you understand this point? I should make a better graph. Arey yaar. So I just made this graph. Did you understand this point or not? And but these zeros I will not make, because 0 plus some value 0 only, 0 plus some value is 0 only, 0 plus some value is 0 only. So this is the final transfer characteristics. What does this shows? That here your V02 was equals to minus V in, right? And here your V01 was equals to V in. So V01 was equals to V in. Both should be subtracted, right? V01 was equals to minus V in, sorry. V01 was equals to minus V in. V01 was equals to minus V in. Look, for V in greater than 0, what is your output? V02 minus V in 1. So for V in greater than 0, what will be your output? What is V02? V02 is 0. Minus, what is V01? That is minus V in. So what will be your output? That would be equals to V in only. So this is the graph of V0 equals to V in. Positive slope. Say yes or no? This is the positive slope, right? And for V in less than 0, what is your V0? V0 is V02. What is V02? V02 is minus V in. Minus V01. What is V01? For V in less than 0, it is 0. So what is your output? Minus V in. So this is for V in less than 0, your V0 is minus V in. For V in less than 0, your V0 is minus V in. So here there is negative slope, here there is positive slope. This is your final answer. So this should be kept in a box. Right. So this is the final characteristics. So for positive value, it will give the value as it is. For negative values, it will give positive values. So if I draw the graph taking the input waveform from sum of the previous circuits. Where is the input waveform? This is the input waveform. How will the output look like? For the final output. For the final output, how will the output look like? One more page. For 0 to t by 2, if Vin is greater than 0, if Vin is greater than 0, V0 is equals to Vin only. V0 is equals to Vin only. For Vin greater than 0, V0 is equals to Vin. So the same waveform will come. And for V0 less than 0, for Vin less than 0, V0 is equals to minus Vin. So whatever the waveform is downward, that will come upward. For Vin greater than 0, it will become as it is. For Vin less than downward, for Vin less than 0, it will come upward. And it will go on like that. Right? This will be A. So this is full wave rectifier. That's why I told you it is full wave rectifier. So this particular circuitry was full wave rectifier. So I hope this lecture was intuitive for you. I hope you understood a lot of new things. So yeah, we will meet in the next lecture. We will solve a lot of assignments. We will solve a lot of question. Very easy question we are going to solve. So in this video, we understood the concept of full wave rectifier, half wave rectifier. So whatever the notes you are having, just revise those notes. Try analyzing the circuits on your own. Just see which diode is turning on, which diode is turning off, how there is 0 ampere current, which kind of feedback is there. And in the end, you will be very, very comfortable. So in the next video, we are going to solve the assignment. Meanwhile, my eyes are aching. क्या हो गया भाई आंख में? आंख दुखने आती है ना, मेरे ख्याल से वो होने लगा है. I am literally working 16 hours a day because I have to go to the office, then I need to record the videos. So yeah, so I'm facing a lot of health issues nowadays. So we need to solve this assignment. This is the first question. This is the second one. This is the third one. You need to find the expression of I naught. Find the expression of I naught. I naught is not a function of ZL that I have already written. You need to find the function of I naught. Then this question, this is a very interesting question. Here, it will clear one of your doubt as well. That some people would be saying, sir, you taught us log amplifier, anti-log amplifier, but there you did not consider whether the diode will be on or off. Why did not I consider that? Because the expression was given, the value was given that diode current is this. Here, what kind of model we were taking? Here we were taking the exact model, this model, this exact model we were taking, this model we were taking. But in the previous case, in those cases when we studied full wave rectifier, half wave rectifier, which model we were taking? Piecewise model, piecewise linear model. In these cases, piecewise linear model. This model we were taking. This model. Till 0.7 it doesn't turn on, after that it turns on. So this model we were taking. We were not taking the exact model. Right? Exact model is something like this. Not taking this model. We were taking the piecewise linear model. That's why the analysis was different, but here the analysis was different in the case of log anti-log amplifier. So in this question you will be able to understand this point. In this question you will be able to understand these points. This question will also be a good. Here the input is changed to 5 millivolt. In the previous case the input was minus 1 volt. Then this question is there, you need to find the potential at node X, Vx potential you need to find. This is also a very good question. Very easy, but some students some students can make a mistake here. Okay, you need to find the average value of V naught. This should be done by yourself. This also you can do. You need to find the value of V naught. This is also very easy. Yeah, this is a good question you can say, or it is very easy only. There is amplifier, log amplifier, anti-log amplifier. These expressions are given. Then you need to find the value of V naught. Okay, that's it. These are the questions only. That's it. Okay, let's meet you in the next lecture. We will solve the assignment. Thank you.